Hello, everyone. Thanks for choosing my talk. I'm very delighted to see so many of you here. Today, I'm going to share with you my experience in running web applications in the cloud without having to use any EC2 instance or Docker container. It's all happening without servers. Serverless. It's a big buzzword these days, but it doesn't mean that there are no servers at all. There are servers. The code is not running by some unicorns in the cloud. There are servers underneath. In fact, this is quite complex architecture powering the AWS Lambda service. But for the users of that service, it's all hidden. We don't need to worry about operating systems, the kernel version, firewalls. It's all abstracted out nicely. As developers, we can focus on the thing we understand the most, which is our code. My name is Thomas. I work in the log team as a technical lead. We build authentication system. It's part of the family of Collab products. Before we start talking about the new and shiny serverless architecture, I'm going to take a step back and have a look at some more traditional ways of deploying web applications in REA over the years. I've been with REA for more than 6 years, and I've seen many different ways, tools for deploying web applications. For example, we used to package all our application code and deploy it to NFS server. The NFS volume was mounted by every machine in the data center, but the code dependencies, like libraries that the code was using, were managed by in different places, usually in Puppet manifests. Some iteration for that solution was to use system packaging solution like RPM. We used to package the code as RPM. We defined some dependencies, and we just were updating the RPM version in the data center on our boxes. We've added some tools like DeployBot, Start Deploy. The tools made the whole process more robust. Then with the whole journey from data center to the cloud, we kind of took what we've learned from our data center days and started deploying systems in a similar way. Instead of provisioning VMware instances, we are provisioning EC2 instances from AMIs. And containers changed everything. As you all know, these days we package the apps as Docker containers, and we either use rea-shipper to deploy them. If not shipper, then we use something like ECS or Kubernetes, but the container is the common denominator these days. So I was talking about all those different solutions, approaches, to highlight one thing that they have in common. They try to move our application code to some place in production and execute that code in response to HTTP requests. Now, according to Wikipedia article on AWS Lambda is a cloud service that can run your code in response to events. So it's a very good fit for this purpose. If only the events could be HTTP requests. But here comes the API gateway, which acts exactly as the HTTP request events for the Lambda function. You can package your code as a Lambda function. You can put API gateway in front of that, and it will be executing the function in response to HTTP requests. Think about API gateway like an elastic HTTP server in the cloud that can scale in response to the demand. In fact, it's not a new idea in REA. We have a number of systems that are currently running in production using those resources. And they include new homes BFF, audience select API, power profiles API, which is part of the agent Elevate product. And my team is building log API, and we deploy it to Lambda as well. So now that we have some basic understanding, basic idea of how we can deploy the code to AWS Lambda, let's have a look at some main components of this deployment, and let's compare them to the traditional container-based deployment that we are all familiar with, that we get by using a rea-shipper. So as developers of the application, if you want to deploy it to production with shipper, we need to put it inside a Docker image. So the components that we put inside the Docker image are the operating system. We need some kind of web server that will be running the controllers in our application code. We add some config to it, and we run the web server as a Docker container inside an EC2 instance. We need to define some autoscaling rules. So for example, based on CPU usage or time of day, EC2 instances are going to be deployed into private subnet for security reasons. So we need to think about the security here as well. And we send the internet traffic to the instances using the elastic load balancer. So as you can see, we need to also think about the underlying infrastructure. We need to set up VPC with the subnets, NAT gateways, and things like that. Whereas the application deployed with the serverless components like AWS Lambda and API Gateway, this whole architecture is much, much simpler. We deploy our code as a Lambda function. We create a zip file, upload it to a S3 file, and we configure API Gateway to execute this Lambda function whenever there are HTTP requests coming to the application. We don't need to worry about auto-scaling because Lambda scales automatically in response to the demand. So when we look at those two diagrams side by side, we can clearly see the reduced complexity. And the main reason why it's simpler is because of the fact that Lambda hides the details about the infrastructure. So now that we know that we can easily run our code in production, we may be thinking about some other concerns of running application in production, like alerting, monitoring, scaling, security, and so on. For example, blue and green deployment. So let's dig a little bit deeper. Blue and green deployments, I hope that it's a solution you are familiar with. It's basically a solution that eliminates downtime during the deployment and is reducing the risk of deploying a new version that has some issues with it. How it works with, for example, application deployed with a rea-shipper. Our initial state, EC2 instances behind load balancer. When we want to deploy a new version of the application, we create similar environment but running the new code. This environment is not yet serving the production traffic. We wait for this environment to report the healthy status. When it's healthy, we start sending traffic to those instances, and at the same time we terminate the old nodes. That's how it works. So how can we achieve similar solution with AWS Lambda and API Gateway? So this is what we do with log API. We keep two copies, exactly the same copies of the production environment, but only one of them is serving the real production traffic. The other one sits there for the only purpose for the preprod one is to test whether the new code is healthy, pretty much. So when we deploy new code, we update the Lambda function code in the preprod environment, run some health checks. If we're happy with the response, then we do exactly the same thing in the real production environment. Now with autoscaling. As we know, autoscaling is very important in the production environment. With the solution based on Lambda function, we don't really, sorry, oops. Did I press the wrong button? Oop.
There's no projector light coming through.
So while we're waiting for the projector to come up, I'm going to talk about the monitoring. To monitor the deployment in the deployment to API Gateway and Lambda, we are basically relying on CloudWatch metrics. As both Lambda and API Gateway integrate nicely with CloudWatch, the metrics we are the most interested in are the Lambda invocation errors, API Gateway 500 response codes, and the number of concurrently of Lambda functions running at the same time. The application can also be monitored from outside using New Relic Synthetic that is able to monitor performance and health of the app. If we want to dig deeper into the performance of the code itself, we can use AWS X-Ray, which is a solution similar to New Relic, but it integrates seamlessly with Lambda function. Nothing back? Okay. Okay, so let's move to another concern, logging. Basically, similar solution that we use in shipperized application. We rely on the 12-factor methodology, which says to log everything to standard output. All the standard output that comes out of the Lambda function goes automatically to CloudWatch logs. API Gateway access log also goes automatically to CloudWatch logs. So we have all the logs combined together in CloudWatch logs. GI, group infrastructure, great. Has a tool, Flukis, that is able to forward CloudWatch logs into Splunk. Configuration, same way as we configure all the other applications through environment variables. So again, we follow the 12-factor methodology here. And we can also use the same pattern that GDE came up with to share some secrets encrypted with KMS by passing environment variables that start with KMS encrypted. Let's move on to security. As maintainers of web applications, it's something that we constantly need to be aware of. There are always some security vulnerabilities coming every day. In traditional environment, we need to patch all the problems that affect operating system our EC2 instance is running on, or the operating system that we put inside Docker container, as well as any issue with the web server that's inside Docker container. And at the end, any library that our application is using, if it's vulnerable, we need to patch. Whereas with the serverless solution, we only need to patch the code. That's it. Continuous deployment. 3 words, it's pretty quick. Those are numbers I grabbed from the recent build of local API. We deploy it to 3 regions, and the whole process takes a little bit more than 4 minutes. So I'm going to stop here, and you don't see it, that's fine. I just kicked off deployment of new version of that demo application. So check it out in about 20 seconds. Pricing. It's very difficult to tell how expensive it is because Lambda pricing depends on multiple dimensions, like the number of requests, the execution time, and the amount of memory we give to it. But assuming that our Lambda has 1 gig of memory, it takes 200 milliseconds to execute, and we send 1 million requests, the total cost is $7. You decide whether it's expensive or not. It all depends. It all depends on the application. I checked against the traffic that goes to the Balix application, and it's pretty much, is at the moment exactly the same at 3.5 million requests a day. Audience Selector API is an app that's used only by internal users. I think this is the last graph generated by Cloudability. I checked the cost for the last 90 days. As you can see, we paid 8 cents for API Gateway and 4 cents for Lambda. The traffic here is around a couple of thousand requests a day. Let me talk a little bit about how API Gateway can be integrated with Lambda functions. What are the models? So in this model, we configure API Gateway in such a way that every endpoint calls different Lambda function. So what are the benefits? For example, we can configure different memory limits for different functions, or we can configure some reserved concurrency for some of the most critical functions. But it's quite difficult to maintain. It's really difficult to run this application on local machine, and the API Gateway is tightly coupled to our Lambda functions. It needs to know about all the endpoints. In contrast, in this model, we configure the API Gateway as a simple proxy that doesn't know anything about what the application can do, and we deploy just 1 Lambda function, all the code. This is the model that we follow in Log API. Our Lambda function is just basically Express.js app with a small adapter that translates event objects into the Express.js controllers. And you can also think about some hybrid model where you run the same code as different Lambda functions, and that allows you to set different memory limits for each of them, and for example, configure API Gateway so it sends the most critical requests to the Lambda function that was given the highest amount of memory. Cool, to summarize, we've explored the serverless components in AWS, specifically API Gateway and AWS Lambda in the context of running web applications. So hopefully now you have some understanding of how serverless application works. We know that the benefits include immediate autoscaling, fast deployments, handling of spikes in load. Cost is relatively low. It all depends on the amount of traffic that your application needs to process. One of the benefits is that it's free when it's not used. It's very useful for example, QA, test, or some pre-prod environments. And also, it's quite easy to take this application and deploy to another AWS account or another region. because we don't need to worry about infrastructure, for example, setting up VPCs and subnets. That's all I have for today. If you're interested, I invite you to the SIG serverless channel, or you can check out the demo I prepared for today. And my presentation is also available on GitHub. Thank you. Any questions? You need to help me with drawing.
Thanks for your talk, Thomas. I like the way you integrated projectorless with your serverless talk.
Thanks.
You described sort of 3 ways of using API Gateway, sort of splitting up the application code. Have you seen any libraries that help support that, that kind of the different deployment methods of splitting up the app into different endpoints?
Not really. The solutions I've seen basically were based on CloudFormation. So people would just specify different endpoints and send them, integrate them with different Lambda functions. So it was, the solutions I've seen were all manual.
Yeah.
Okay. So how do you run this locally in dev when you don't have API Gateway and things set up?
So because we are basically deploying, developing Express.js application, we run it as normal Express.js application locally. Josh?
How do you handle like cases where your Lambda runs for too long? Like if you have your entire Express app in a Lambda, what happens if it runs over?
Yeah, so we gave it a limit of 30 seconds, which should be enough for any rea-shipper request of reasonable size. Or I think in your typical application, you also configure some kind of timeout on the web server. I think 30 seconds is reasonable time. The Lambda timeouts can be configured to up to 5 minutes. Timothy?
So I might have misunderstood something, but I think you're sort of suggesting one Lambda function per API endpoint. Is that?
I didn't suggest that. I was just talking about different models of how we may be integrating API Gateway with the Lambda function.
Because there's one app that I've worked on here at REA that had approximately 500 routes. And I guess I was just curious, would this model still be something that you would reach for? Or is it?
I honestly don't recommend this model. I was only talking about this because I've seen examples of it. And there are multiple reasons why I don't recommend it. Like the main one, I think, is the tightly coupling between API Gateway and your Lambdas. It's with 500 endpoints, it's almost impossible to manage, I think. And yeah. Oh, the demo. You were late, I think. That's the demo. I knew I wouldn't have time to show you the demo, so I asked the audience to open it on their phones. Do we have time? Yep. Sean?
Are there any stateless web applications that you would recommend serverless or Lambda?
I wouldn't recommend.
You would not recommend?
Yeah, that's a great question. I had some time to think about this. Basically, Lambda has the main limitation of this solution is the number of runtimes you can choose. You have basically choice between Node.js, Python, and Go. I wouldn't recommend to use that for JVM or .NET runtimes because of the cold start time, which is getting in the way with the autoscaling. So I wouldn't recommend that for JVM applications. Or applications really high volume of traffic, because then the cost can overrun one more.
Thanks, Thomas, for your talk. Can you please talk a little bit about
Switch out.
Can you please talk a little bit about the build guide pipeline and the tooling you've got there for the lock project, and is that something that other teams can leverage on as well?
It's typical build guide pipeline, which is first running the tests, then it's packaging the application. In this case, it's basically building a zip file that is being uploaded to S3 buckets. And we have CloudFormation stack. So deployment is about replacing the location of the zip file from the previous version to the new version. So if you want to try similar solution in your project, I think you can leverage our CloudFormation stack. Copy paste for now, we don't have any tooling that can generate it out of some metadata. When I was preparing the demo, I copied the CloudFormation stack from the log API. With few modifications, I was able to create another stack.
Also, while I'm at it, is there any problems you foresee with using this architecture for lock?
Not right now. We haven't come across one. There could be some issues during autoscaling, there's a small latency. It takes about 1 extra second to do the cold start in the Lambda node environment. So we may observe some longer request processing during spikes in the load, but only initially before the Lambda is warmed up.
Cool, thank you.
Thank you.